Okay, so let's get started making some changes to our Mech 232 trainer. You've now picked up your second kit of parts, and that kit includes a new blue illuminated push button, a yellow illuminated push button, and a 2-position toggle. So previously the first 2 toggles were 3-position. They had a middle position with an off. This one is just either up or down, similar to the switches from your Mech 231 trainer. The 2 push buttons are illuminated just like our first 3. The only distinction is that S5, our yellow push button, is wired using the normally closed contacts. Okay, so you know how to physically mount those. You've done that. Go ahead and mount those up to the I/O panel. Remove your screws and install those. And then we're going to need to land the wires on the terminal block up here. And let's take a look at our wiring diagram. So here's the previous wiring diagram that you used before. And you can notice that our toggle switches landed through these blue and white-blue wires to inputs 2 through 5. And our push buttons landed on inputs 8 through 10. We're going to change that now just to get practice of rewiring things. It requires more attention to detail than the original wiring because it's easy to overlook wires that you need to move. And so by swapping our toggle switches and our push buttons, we're also going to need to be swapping whether they're wired as syncing or sourcing as far as the PLC. If you look at originally, we had our toggle switches coming into, like I said, inputs 2 through 5, and the PLC was set up as sourcing, right? The positive was tied to the common. If you look at the new schematic here, it's busier for one thing because we've added a bunch of components, but looking at the PLC, I've now moved the blue and white wires down to inputs 8 through 11. And so to do that, I had to change the common for inputs 8 from 11. Previously, it was the negative side of the supply, and now it's the positive. Let's just go back and look at that once more. So previously, terminal 10 was tied to the negative of our DC supply. Now, terminal 10 is tied to the positive, and our toggle switches land on wire inputs 8 through 11. Vice versa, the push buttons now land on inputs 2 through 7 because we've added 2 more, and common for terminal 1 is now negative, whereas before it was positive. Down on the terminal block side, go ahead and check comparing the new schematic to the old one, and you'll see that we have added 2 more push buttons, and you can see that S4, our blue one, is normally open just like S1 through 3 were, but you'll notice S5 is a normally closed. Still using gray for the common, and we're using the same common of positive here for all our push buttons, but now we're running the switch leg from S4 and S5 coming over here to terminals 17 and 18. We also add toggle switch 3, and you can see it's only got 1 set of contacts now, as opposed to T1 and T2 that had 2 positions. And so go ahead and land those wires, 2 new gray wires, a new brown wire, and then a new white, brown, and purple going to 17, 18, and 19. So you have enough terminal blocks to add out 17 through 26. Okay, so you're going to land those wires for the 2 new push buttons, blue and yellow for the toggle switch, and also for the lamp components of the blue and yellow push button. So looking at the schematic, you now have a new white wire, brown wire, and purple wire on the input side, and then you're going to have the new yellow and blue here at terminals 13 and 14, and 2 new black 0 volt to the 15 for the lamp components of push button 4 and 5. At this time, we'll also go ahead and land the wires for the potentiometer that we're going to use in a future lesson here about analog inputs. So again, it will connect to positive, negative, and the signal wire will land on 20. So verify that once you've made all your additions, that your the I/O panel side of the terminal block looks just like this. Verify each wire here is connected under this new schematic, and then also go up and do the same for the PLC. So on the input side of the PLC, we're going to have swapped our two commons. We're going to have moved our push buttons down to the first group of inputs, moved our toggles to the second group of inputs. And on outputs, at this point, you'll have added two outputs for the yellow lamp and the blue lamp. There's a couple shown here on the schematic related to the stepper drive that you haven't done yet, but you should have the ones for all the indicator lamps. So that's input 1 or indicator 2, indicator 1, 2, 3, 4, 5, and then you should have the two outputs that are controlling the control relays for the DC motor. So that's the clockwise and counterclockwise. So the only two you wouldn't have, or actually three that you wouldn't have wired yet, are input or output 0, 0, the pulse output for the stepper drive, output 0, 3, the direction to the stepper drive, and then the enable. So that's output 6, this brown one. Those three you shouldn't have connected yet. Everything else should be there. Should have 26 terminal blocks now for the I/O panel, and go ahead and get all that wired up. It also, one thing that you can mount up at this point would be these 3 terminal blocks that are going to mount next to the DC motor. So you can see I've got them up here, black, red, and blue. You already likely have the wires from these two black and red power supply wires for the DC motor reversing landed somewhere else, and that's fine. But go ahead and bring the positive and negative supply to this terminal block set and get the blue terminal block in here along with the clamp on the end, so that in the future lesson we can land our proximity sensor there. Okay, that's good for now. Once you have all that wired up, I'm going to provide a test program that you can download to your PLC to verify that everything's working. So at this point you should have completed all the additions to the I/O panel. You should have 5 push buttons wired, and the 5 lamps connected to them should all be connected. You should have 3 toggle switches connected as inputs, and once you're confident that you've completed all that wiring correctly, you should also have the DC motor control relays connected. Once everything, you feel confident about all that, we're going to download this program to the PLC to test the function of all our inputs and outputs that we have worked with so far. So looking at this real simple test program, you can see on the right hand side I have each of the lamps, red lamp, green lamp, orange, blue, and yellow, only on one rung. I have a number of different cases where I want each of those to be on. So to test the push buttons, if I push the red push button, the red lamp should turn on. Green push button, green lamp, etc. So that's the first option for turning on each lamp, is pushing the actual push button it's associated with. The next option is to test toggle 1. So if T1 is in the up position, it should turn on the red lamp, the green lamp, and the orange lamp. Basically the top row of lamps should turn on if my toggle 1 switch is up. If toggle 1 switches down, that's these next 2 branches here, that should turn on the lower 2 lamps, so the blue and yellow lamps. And then my last case is using toggle switch 3 down here. I'm using toggle switch 3 and an on-off timer to create a flashing bit, so that if toggle 3 switches up, then all of the lamps should flash. So I've uploaded this as a file to the assignment that you can download. Go ahead and download it to your PLC and then run it, and it should look like this. So if I press PB1 red lamp, PB2 green, etc. for the push buttons, if toggle 1 is up, the top row of lamps should be on. If toggle 2 is down, the bottom row is on. If toggle 2 is up, the DC motor should run clockwise. If toggle 2 is down, the DC motor runs counterclockwise. And lastly, if toggle 3 is up, all the lamps should flash. So go ahead and try that. Hopefully it all works. If it doesn't, start troubleshooting which component isn't working. And that's a good exercise for you to figure out, did I make an error in landing the wires from the terminal block from the I/O panel to the terminal block, from the terminal block to the PLC, Did I mislabel one of the inputs in my PLC, etc.? So that is the last step for testing our new digital I/O configuration. And as far as digital inputs and outputs, this is almost complete. We'll add one more input here soon for a proximity sensor on our stepper motor. But hopefully you have it now functioning like this. If not, let me know what you're struggling with. Thanks.